Hello everybody and welcome back. We're going to continue our look at the 2002 Fermat paper. Specifically, we're going to be looking at question number 12 in this video. How many three-digit positive integers are perfect squares? Okay, so what's a perfect square? Well, a perfect square is a number that happens to be a square of an integer. So 5 squared 25 is a perfect square. That's a good example there. So we want three-digit positive integers that are perfect squares. So if you are the square, which is k times k, of an integer, then you are a perfect square. Now we want perfect squares that are 3 digits. Well, 3 digits means that we're in a very particular range. We are less than or equal to 100, greater than or equal to 100 and less than or equal to 999. Okay. Well, I've got a nice little inequality here. If only I could get values of k. I could see which integers k can be, and that'll tell me how many perfect squares we have. So let's square root every part of my inequality. It's not going to change the inequality itself. So square root of 100, that's 10. So less than or equal to. That cancels out. We get k. And the square root of 99. Now that's not a nice number. But we can work it out on our calculator because calculators are allowed. So it's 31.6. Basically. So what integers are in this range? So k is an integer. So k could be 10 or 11 or all the way up to 31. It can't be 32. That's beyond this range. So how many numbers are in here? Well, it's a list of consecutive numbers. And if I have a list of consecutive numbers, so m plus 1 all the way up to n minus 1, n. If I want to know how many numbers are in that list, I do n minus m plus 1. So there are 31 minus 10 plus 1. That should be 22 values for k. So that's 22 three-digit perfect squares. Was 22 one of our answers? There it is. It's B. Now, as a good little exercise, because I always suggest that people know their perfect squares up to a certain amount, I'm actually going to write each of these out and make sure that they are, in fact, three-digit. So what do we have? We have 10, 11 squared, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and I will do 32 just to make sure, but that is 1024 and that is a step too far. So all these should be squares, I guess. 10 squared, that's 100. So 30 squared, that's 900. 31 squared, that's 961. That's three-digit. That's great. 29 squared is 800 and something. I'll come back to that one. 27 squared is 729. 676, 625. I know this one because it differs from 24 squared by 100, and that one always sticks out in my mind. 23 squared. I'll come back to that. No, that's 529. 11 squared, that's 121. The easy ones here are the smaller ones. 196, 15 squared, that's 225, 256, 289, 324, 361. Now I'm questioning whether or not 961 is right. 400, 441, 484, 28 squared. I think that's 784, but I'll double check that on a calculator. And this, I think, is 841. So there's a couple I want to double check because I don't always have all these memorized. 28 squared, yep, got that one right. 31 squared, okay. And 29 squared, just double checking that one. Yep, 841. Alright, so my memory didn't fail me there. I usually recommend people know up to the first 20 squares, but the first 30 is great as well. First 40, if you really want to do something outstanding. First 100, although 76 squared doesn't usually come up very often on math contests. But we've got all of these written out, and they are all, in fact, 3-digit. And the next one that we would have tried, 32, that's 4-digit. So we really have taken the time, double-checked our work, and we do have 22 as our possible answers there. So that concludes question number 12. We're going to take a look at question number 13, but we're going to do that in the next video. I'll see you guys then.